Here we're going to look at compound areas. Compound areas are formed by putting two or more areas together. In order to find the area of such a region, you need to separate the region into constituent areas and then evaluate the areas. Getting the final answer will be a matter of either adding areas or subtracting some areas from others. It depends how you've separated your region. Let's consider an example. Here we have the curve y equals 4x minus x squared and the line y equals x, and we want to find this grey shaded area just here. We want to find the grey shaded area between the curve and the line as shown in the diagram. This can be evaluated as the area shown on the left here, which is the area between the curve and the x-axis. Take away the area on the right, which is this triangle just below the line y equals x. We need to know the coordinates of the point of intersection of the line and the curve. That will give us the x-coordinate just here. To find this, we just solve the equation simultaneously. So we have x equals 4x minus x squared. This gives us x squared minus 3x equals 0. X times x minus 3 is 0, so x is 0, or x is 3. Clearly, x equals 0 is the intercept at the origin. The one we want is x equals 3. Since the line is y equals x, if x equals 3, then y equals 3, so the intercept is at the point 3, 3. It follows the area on the left is the integral from 0 to 3 of 4x minus x squared. Evaluating this integral, we get 2x squared minus x cubed over 3 from 0 to 3, which is 2 times 3 squared. Take away 3 cubed over 3, take away 0. When we put 0 into here, it will evaluate to 0. Gives us 18 minus 9, which is 9 square units. We could integrate to find the area on the right, but note that it's simply a right-angled triangle of base 3 and height 3, so its area is a half times base times height, which is a half times 3 times 3, which is 4.5 square units, making the composite area 9 take away 4.5, which is 4.5 square units.